Okay, now let's see this question. This question came in GATE 2014 for 1 mark. The question is, suppose depth first search DFS is executed on the graph below starting at some unknown vertex. So we are allowed to start DFS from any vertex. Assume that the recursive call to visit a vertex is made only after first checking that the vertex has not been visited earlier, which is the standard case in any DFS, right? So that is they are following. Then the maximum possible recursion depth, including the initial call, is what? So basically, we have to see that in this graph, what can be the maximum recursion depth? Okay. Uh, so we can see that, okay, let's say we start from here, then what can be the different ways in which the recursion can happen? So let's say here, after here, we visit something like this, and then this, and then this, and then this, and let's say we are visiting something like this. Okay, so here this is one way of doing DFS, but in this case, whatever is the recursion depth, actually we can do, we have to basically maximize the number of recursive count of recursive depth. Okay, so here let's say in place of this, if we would have done something like let's say something like this, let's say, okay, something like this, then what do you think? This will be bigger, right? So let's start from a clean slate and try to understand that what can be the maximum depth that in a particular recursion trail, how much more of the edges, more and more of the more of the nodes we can accommodate in a particular recursion. Okay, that is we are going to see. So let's start with this. Firstly, this slot, this whatever square. In this square grid, there is a there are 9 different nodes in this grid, and what is happening is that, is there a way in which we can traverse all the 9? So let's say we are coming from this side and we are coming here, then we can see that clearly there are many ways in which all the 9, so let's say there is one way, in this way all the 9 can be come in the recursion depth. Another way can be something like this. Okay, another way can be something like this. Okay, so let's take any one way. So let's say we are going to take this way. So this, and all this. So all the 9 are covered. Now here. Now if we go from here this side, then only one edge is one node will come, and that will be the end of the maximum depth. So we want to maximize the recursion depth. So we will not go this side, we'll go this side. Again, here there are many ways, but there are 10 nodes in this grid, and then there is one this node. So sorry, 9 nodes here and then one node here. So overall there are 10 nodes in this part. Can we include all the 10 nodes in the recursion in the recursion? So let's see. Let's try. If we do something like this, then see, if we go here, then this is left. If we go here, then this is left. Okay, let's try something else. So let's go here, and then here, and then here, and then if we go this side, then it will be the end. But if we go this side, then if we come back here, then we can go till here only. So we can see that there is no way we can include all the 10 nodes. In fact, at max we are going to include only 9 nodes. So like here, and then either we include this or we include this. So let's say we include this. So in that case, let's say we are starting recursion from here, then maximum 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So basically 9 here, 18, and this one extra node, so 19. So 9, 18, and then this 19. So overall there the depth is going to be 19. Why? Because see, when we are starting recursion from here, then after that the depth is 18 obviously, but they are saying that including the initial call. So whatever the initial call is there, that also you have to count. So overall it is going to be 18 plus 1, which is 19. So the answer is 19.